Okay, welcome everyone to today's instruction class on byte stuffing. What is this byte stuffing anyways? You have already seen the bit stuffing part in the previous session where in order to differentiate the flag from the data, we had to insert a zero if there are consecutive number of ones in the data. Number of ones, consecutive 5 number of ones it's repeated continuously in the data. We have to insert a zero to differentiate the data from the flag. Okay, that is the case in case of we are transferring the bits. What's the case if you are transferring the characters? Okay, even to transfer the characters or the data and to indicate to the start of the data, character data, and end of the character data. If you look at the total frame which is being shown over here, okay, you can have any input, you can provide any data, okay, to this packet or package of data. You have a start flag and a end flag. You can have any character as a start flag and any character as a end flag. The question is what if the characters of the start flag and the end flag, okay, they become part of the data itself, the character data that you are transmitting. Okay, if as you can see as you can see there is a D over here and I put input as db80, and if you see at the beginning part of this frame that these are repeated twice. There is a D which is part of the start flag, there is a D which is part of the data. So at the receiver there is a confusion that to consider whether to consider the D which is part of the flag as flag, or D which is part of the input or data as a flag. Okay, in order to eliminate these confusions irrespective of any characters, okay, if it is D or in case the character that I'm choosing for start flag to be I, okay, there is still a confusion, okay, if I insert dbt as a data as I is repeating again, okay, which creates a confusion to consider I which is part of the start flag as the starting of the data, or I which is part of the data as the, okay, start of the data. And similarly if you have Z or Z as a end flag of a frame, okay, if there is a Z, okay, at end of the flag prior to the end of the character string prior to the end flag, there is a confusion whether to consider the Z which is part of the input or a data stream as part of the end flag, or the Z as end flag itself. Okay, there is a confusion. Okay, we in this case we follow the same idea as that of the bit stuffing, where in order to eliminate the confusion between the data stream and that of the flag, we insert a additional bit. Okay, in this case what we do in order to eliminate the confusion between the flag and the data itself, we insert additional character. Can you see, apart from the D which is start flag and the D with a character which is part of the input or a data, to differentiate these two characters we insert one more character which is same as that of the flag. Okay, if you insert if you make such a arrangement, if you insert additional character which is same that of the flag, okay, upon receiving this set of characters the receiver will get to know, okay, the difference between the flag and the character if it receives successive characters. Okay, if the D is repeated twice, if the D is repeated twice, it means that it is to be considered as data. As you can see, the D is repeated twice as part of the input. Okay, if D is repeated twice, okay, there is no, in order to eliminate the confusion, okay, the repeated character are considered as data. Okay, if D is, okay, a stand alone character, okay, if D and any other character coming after D which is different than D, okay, it is very easy for it to differentiate. If D and D starts, at the beginning itself, where one D is flag and another D is data. To eliminate this confusion, they insert another D. If there is consecutive D as part of the data, then receiver understands that it is data, not as the flag. Okay, but in this way, the confusion between the flag and the data are eliminated. Similarly, if you have I as a start flag and I is also as part of the input, okay, you insert additional I, one more I, to differentiate data from the start flag, because the case here is that the I is character as a character is a start flag. I is also part of the data. What by inserting additional I, if the receiver encounters consecutive I, it is understood that the I character that you are sending is data, not a flag. Okay, let's see the execution of this program. Okay, let's see the execution of this program. Okay, when you execute this program, this is what you see. Okay, you have been asked to enter a character. You have been asked to enter the characters to be stuffed. Okay, as per our example, we have taken dbit as a input. This is your character stream that you need to be transmitted. Okay, now it is asking for the start flag. Okay, let us enter as per example capital D, and we enter once again. Okay, we enter the last character to be as capital Z. Okay, and when you press enter, the output will be like this: the first starting flag, the end flag, and there are two consecutive Ds. As you can see in the output, there are two consecutive Ds, and remaining characters remain as it is. Okay, this is the output what we get, irrespective of the any character that you enter as part of the data to be transmitted. Okay, any starting flag and ending flag could be chosen by your choice. If that is part of your data itself, the flag that you are choosing is part of the data itself, then additional character is inserted to eliminate the confusion between the character, data that you are transmitting and the flag. Okay, okay, so to eliminate the difference, that's what we do. Okay, let's go back to the slides. Okay, this is what the output we see: D followed by double D, BIT, and then Z. Okay, this is what your actual output looks like. Okay, let's see the different iteration that we go through. Let's look at the program. This is your program. Okay, that will be practicing as part of the first experiment, I guess, the second program. We have several initialization at the beginning of the program, and you have been asked to enter a character. Okay, we are using percentages. As you can see, we are reading the character directly into the you know uh, string, an array called as the a. Okay, remember, we are not using percentage c, we are not using loop over here, we are using simply the percentage s, which is a specifier. Okay, which is a specifier to gather the data, to read the data into the array a. Okay, similarly, we are asking for a single character and second character. The first character is the start flag, the second character is the end flag, and we are doing several initialization. Okay, let us see what are this initialization, how the internal content of these arrays are taking place, initialization of these arrays are taking place, and how many times we do the iteration for the example input we have taken. Okay, first thing first. Okay, at this part we have a character array of 30 in size, and we have uh, and an array called fs with a 50 in size, and we have initialized that one to a okay empty string. Okay, double quote without anything represents a empty string, and two more character variable s and ed. Okay, x of 3, s of 3, d of 3, and y of 3. X, s, d, and y, all these variables are arrays of length 3. Okay, first we are asking for a character array, or simply a string into the variable called A. Secondly, okay, we are reading a beginning flag character or a start flag character, and that's being read into variable called SD. Okay, and a end flag character which is Z, which is being read into a variable called ED. Okay, at the initialization, the first statement we are doing some initialization where x of 0, s of 0 and s of 1 is been initialized to SD. Okay, the SD, okay, the character has been initialized to, as you can see, to the character D, which is the start character, start flag character. Okay, the x of 0 holds D, that's what the initialization that we are doing, and s of 0, s of 1 has been initialized to the same character D. Okay, we'll see the use of these arrays as and when we see the iteration of the loop. And then x of 1, s of 2 has been initialized to, okay, null character. Okay, null character. Okay, as you can see, the second element of x array has been, okay, assigned with a null character. Okay, or end of string character, you can see. And also s, the last character, that is the second position of the s array, has also been assigned with another null character. Okay, together if you read it as a string, along with a null character forms a string. Okay, as we will be using some string operation on this variable, we are making sure that every array that we have been initializing with some character ends with a null character, to make it easy for us to use them as an, string rather than a set of characters. Okay, use them as a string, okay, rather than set of characters or array of characters. Okay, next statement, y of 0, d of 0, d of 1 has been initialized to ed, the end character. The y of 0 is z. Again, the d array is initialized with the first two characters or locations of this d has been initialized with the end character, end flag character. Okay, zz repeatedly. And then d of 2, y of 1, as you know, okay, the second character of the y array has been initialized with the null character. Okay, and the second the third character, okay, in this case the second position of the variable array d has been initialized with the null character. Together null character and the series of character form a string like formation. Okay, this arrangement will make us easy for us to deal with these variables as string. Okay. Okay, then as you can see, we are using a string cat operation, which stands for the string concatenate operation, which is going to concatenate, okay, x to the fs. Fs, as you know, is a empty string that we have already declared, which is of size 50, where the variable x holds, as you can see from the previous slide, the variable x holds a single character string. Okay, with the only character available is d. Okay, now we are appending that to the fs. As fs is empty, it only adds to the empty string, we are adding the x string, which results in fs to be like a string of single character d, which makes the start flag character, where d makes the start flag character. Then moving on, we'll enter the loop in the program. Okay, we have I is equal to 0, I less than string length of a. Okay, the string length of a that we have taken, the character that I have read into the variable a is 4 characters. Okay, dbat, that's what we have entered. Okay, so the total length of that variable in this case is that arrays in this case is 4, and we are using I plus plus. At the initial point, the variable I is initialized to 0. We are taking some intermediate array over here. We are initializing t of 0 to a of y. What is a of y? A is total as an array is dbit, as we have seen. Okay, the ith character, the 0th character of array a is d. Okay, we have entered it as d. So the t of 0, the array, the first element of t becomes d, and the second element of t becomes a null character. Together d and then null character forms a string. Now this is your temporary string. Okay, now you are checking. Now you are checking if the very first character that you have entered into the t is same as that of the first, flag character or the start flag character. Okay, you are checking the first character itself that you're entering, or any character that you're entering uh, into the array or taking from the array, okay, is equal to the start flag character. You're simply checking, you are taking a character from an array and storing it in a temporary or intermediate array called as the t, and you are taking every character at a time, and you are taking every character at a time of a that is being stored in t and comparing that against the, okay, the start flag character sd, that is known to be storing the start flag character. You compare that one. If it is that turned out to be true, you perform this operation. Okay, yes, it is. In this case, the first if condition is executed is because the first character that you're entering is same as that of the start flag character. So if that is the case, you're appending, if you are appending s, small s to fs. Okay, what is s? As you can see, the s variable is turned out to be a string of 2Ds. Okay, the s variable or s character array turned out to be a string of 2Ds. Okay, that's for what you are concatenating, or in this case appending. Concatenation, append, they are they means the same. You're appending s to the fs, which results in a fs results in this string. Okay, a d you already inserted at the earlier, okay, at the previous statement. Okay, now you're adding, as the condition is satisfied, you are adding double d, okay, which results in or gives an effect of adding, okay, double d's. Okay, as you know, to avoid the confusion between the start flag and the data itself, you are inserting one more d. Okay, the total flag, sorry, the total array becomes a string of three characters, d and then d, and the else part in this case fails. Okay, and as the if is executed, else part of the loop won't be executed. Okay, and then coming to the next loop, I becomes 1. Then in this case, a of I turned out to be uh, b. Okay, the second character. Okay, as I is 1, you're going to fetch the second character from the array a, and you're going to store that one in the 0th position of t, and the second next character turned out to be a null character. That t is now is a array of single character b, array of single character b, or a string of single character b. In this case, the first if condition fails, because when you compare the content of t with the, you are checking the content of t to be, if it is equal to the, the first starting character flag or not, the start flag character or not. Okay, that was successful earlier in this case. Now the same condition won't apply. This won't be successful in the second iteration, and the else part, it comes within the else part. You have two more if else, where the first if fails, where in this part you are doing the comparison of the characters in the t against the end flag character. Okay, in case of end flag character is same as that of the data that has been entered into t, you make sure that you insert one more, okay, end flag like characters along with the newly inserted characters. Okay, that's what you're doing. The same operation that has been done for the start character, okay, the start flag character over here, the comparison will be done for the end flag character at this point. Okay, in this case, in the second iteration, both if statement fails. Only the else part in the second if else, condition, okay, will be successful, which concatenates t to the fs. Okay, this is the default operation. If everything is placed, this has to be executed. Fs will be concatenated with the string t. What is string t? A single character string, which is turned out to be, that character turned out to be b. That is the second character of a array that we have entered as the input data. Now after earlier fs add triple d, now for the third position, that b will be appended. B will be appended to make a string of 4 characters. Okay, now this is where the second iteration ends. Now in the second iteration, I becomes 2. Okay, the third character of the array, now as I is 2, the second position, in this case the third character of the array is reading to the array called as the t intermediate array. Okay, I, and then the second position or second character turned out to be null character. That's what we are doing here. Okay, as the newly entered character into the T, which is I, is neither equal to the start character flag nor equal to the end character flag. Hence, both if statements fail. The only statement that is executed in this iteration is again the string concatenation of fs comma t. Okay. Earlier we had triple D and B. The recently entered character into the array T is I. So the total string becomes array of 5 characters, string of string of 5 characters. Now the fs is string of 5 characters. Now moving on, in the next iteration I becomes the third character, or in this case the fourth character, the third location of I, as I is 3. In this case the fourth character of I will be read into the intermediate array, which is T. Okay, dbit, the last character of the input that we have entered, and the second position of T, that is the second character, or the first position in this case as per the index. Okay, will hold the null character to make a single character string. Okay, in this part, this T that we have entered is neither equal to the start flag character, and I guess the first if part is missing over here. Okay, this part is missing from this slide. You can assume the first if part is not executed. It's because the T character is not equal to the start character, nor it's equal to the end character. Okay, as both. Okay, in this part, as you can see, we are, as I have not written the statement, we can go back and look at the program. Okay, in the second if part, if you can see, we are comparing every character of the T, okay, with the end flag character. Here in this case, we are comparing the every character of T that has been entered into a intermediate array T with a start character flag. Okay, start flag character. Okay, similarly, we are comparing the T of 0, that every character that enter into the array T with a end, flag character. Okay, this statement I have not written there. Well, the example that we have taken, okay, won't execute this statement at all. Is because we are not entering the end flag character to be any character which is not present in the input that we are entering. In our case example, okay, we'll see more execution of a different input. We'll see that one later after the explanation. Okay, in this part the second if also not executed. We were at the last loop. Okay, and then the last, by default the last statement is executed, which appends the recently inserted character, which is T, into the fs, which results in a complete formation of a flag, formation of the frame. Only the end flag character need to be inserted. That we'll see later. Okay, when the control comes out of the loop, that's what we going to do. Okay, in this case, first two if, okay, as if it's missing, you assume the first if don't execute, the second if don't execute, only else part of the second if else block is executed, which is going to form a complete string like this: the triple D bit, which is the recently entered character, recently read character from array I. Okay, in the next iteration I becomes 4, the condition fails, the control comes out, and we are going to execute the last statement, which say fs comma y. The y turned out to be a single character array. Okay, well, that character turned out to be the end flags character. Okay, where y is an array of a single character. Okay, which is also a single character string. Well, that array character turned out to be the end end flag character. And finally we are going to form a complete frame like this. Okay, the start flag character, the end flag character, intermediate data. If as the data is being repeated in the the character of the flag has been repeated as part of the data, we are inserting one more D. This is what the output we have seen. And the last statement is going to display the whole content of fs, which is triple D bit. Okay, and as we are using percentages, there is no need for us to use the loop. Okay, so we see simply it, as we are using this specifier, simply going to display the content of fs as a string. Okay, and if that's the case, the fs should end with null character, and that will be taken care by this string concatenate operation. If you concatenate two string, this operation is going to append the last string to the first string, resulting in a single string, okay, which is attached to the first string. Okay, that's what happens in the string concatenate operation, and this is all about the, okay, this is what the result that you have seen. Okay, this is what all about the, you know, the second program of the first experiment, byte. Okay, uh, stuffing. Why we call it as a byte stuffing, we'll see once again. Okay, why we call it as a byte stuffing? The reason is that if you look at this, okay, a character by ASCII standard is by default is defined by a byte. Okay, as we are inserting a character into the stream of data, that character is a byte in size. We call this operation as a byte, you know, stuffing. Okay, all of you, you can enter your USN now. Wait, you can enter your USN now. All of you, please enter your USN in chat. We'll see another example of the execution before the meeting ends. Okay, dbit, let the first character to be d, the last character to be t. Now, as you can see, okay, please look at this output. As you can see, as the first character is same that of the first character of the input that I'm providing is same that of the start character flag. Additional d has been inserted. Okay, and even at the end case, the last character is same that of the end flag character, and additional t has been inserted over here to differentiate the data from the end character flag. Okay, that's what about today's instruction class. If you are done, you can leave after entering your USN in the chat box. You can leave if you are done with your attendance. Yes, somebody raised hand. Juveria. Yes, USN 80.
Sir, could you please share the video, sir?
ನಾನು ಇದಕ್ಕೆ ಹಾಕ್ತೀನಿ ಕಣೋ, ಅದು ಯೂಟ್ಯೂಬ್ ಹಾಕ್ತೀನಿ. ಲಾಸ್ಟ್ ಟೈಮ್ ಲಿಂಕ್ ಕಳಿಸಿದ್ನಲ್ಲ
ಸರ್. ಅದು ನಮಗೆ ಇನ್ನೂ ಸಿಗ್ತಾ ಇರಲಿಲ್ಲ ಸರ್. ಲಾಸ್ಟ್ ಮತ್ತೆ ಈ ಕ್ಲಾಸ್ ಎರಡರದು.
ಈಗ ನಂದು ಯಾರಾದ್ರೂ ನನ್ನ ನಂಬರ್ ಇದೆಯಾ ನಿಮ್ಮ ಹತ್ರ?
ಇಲ್ಲ ಸರ್, ಮಂಜುನಾಥ್ ಸರ್ ಹತ್ರ ಕೇಳಿದೀವಿ, ಅವರು ಫಾರ್ವರ್ಡ್ ಮಾಡ್ತೀನಿ.
ಮೈ ವಾಟ್ಸ್ಆಪ್ ನಂಬರ್
ಏನ್ ಸರ್?
94.
ಹಾ ಸರ್ ಹೇಳಿ.
82
94 82
07
07
47
47
98.
98.
9482
ಹಾ ಸರ್.
07
ಹಾ
4798.
ಎಸ್
ಇದಕ್ಕೆ ನೀನು ಪಿಂಗ್ ಮಾಡು, ನಾನು ಹಿಂಗೆ ಲಿಂಕ್ ಶೇರ್ ಮಾಡ್ತೇನೆ, ವಿಡಿಯೋ ಲಿಂಕ್.
ಸರ್ 2 ಕ್ಲಾಸ್ ಶೇರ್
2
ಮಾಡಿ.
ಕ್ಲಾಸ್ ಸಿಗುತ್ತೆ ಕಣ, ಬಿಟ್ ಸ್ಟಫಿಂಗ್ ಬೈಟ್ ಸ್ಟಫಿಂಗ್.
ಆಯ್ತು ಸರ್.
ನೀವು ಹುಡುಗರು ಶೇರ್ ಮಾಡ್ಕೊಂಡು ರಿವೈಸ್ ಮಾಡ್ರಿ.
ಆಯ್ತು ಸರ್. ಓಕೆ. ಥ್ಯಾಂಕ್ ಯು.
Okay, if you are done, you can leave. If all of you can leave, I can end the meeting. I have 3 more minutes left. Make sure you to enter the USN before leaving the session. You can leave if you done entering your USN. I still have 9 more people. Okay, shall we end the meeting? Anybody? You can unmute and talk. Okay, thank you everyone. I am ending the meeting now. Thank you. Is there anyone still putting your USN? I hope all of you have entered your USN.